Hello, welcome back PlayBASIC coders, all you retro crazy coders out there. What are we looking at? We're looking at a new addition to PlayBASIC. It's something I was holding over for PlayBASIC 2, but they've been brought forward because I knew I was not going to have enough time to get that done before the end of the year, and I wanted to have this wrapped up in a bow pretty much for the end of this year. Whether we make that or not, there'll be something released soon, as soon as I can get these libraries to work properly. Now, there's a math library, so we've got a basic Vector3 library, we've got a Matrix library, and an intersection library. So we can do some intersections with different types of geometry. So you can do rate of sphere intersection, rate of plane intersection, and at the moment we're working on a fast rate of bounding box. It's kind of working but not quite working at the moment. The big issue with all of these things is the one is a floating point. People know I hate floating point, and yeah, one of the issues with floating point is, if you don't know this, is that it's not very accurate. And when you do comparisons between floats, you get some pretty wonky results. This demo has nothing to show for it at the moment, it's just doing tests. So you run a testing here, and we get a bunch of, we're doing 7 tests here against what's this one? The ray versus sphere intersection. So that's good. It works, in other words, that's fine. These are some constants that define what the return values mean, by the way. And you'll notice this has been implemented as a bunch of libraries. And this is the very reason why I updated the linkdll stuff, was for this feature. I wanted to have this in here, and I wanted these to be pointers that you pass in and then operate on, and whereas previously this wasn't supported, you couldn't do it this way, so it looked a bit ugly. But yeah, it's all working pretty well. We'll go over this this test here. This is probably a simpler thing to look at initially. Got some boilerplate here. We're creating some structures. Now, if you don't know, you can create a pointer of a particular type. So it's a dimension statement. You can use the local statement now too inside functions, and you can declare them as being global as well. That was not possible in old versions of PlayBASIC. There's a whole litany of things now that are possible that weren't before. So we've got a declaration process, and this just creates an empty pointer. This pointer is not pointing at data that's been allocated. Do we do an allocation? So it's pretty much the same as what you would do with a normal typed variable. Just we have the pointer keyword at the end of it. So what are we doing? We're creating a sphere of PV sphere, sphere 2. We're declaring a junk vector of 1, 1, 2, 2, 3, 3, and assigning it to the center field. Now, even this, I think it's worked in older versions of PV164 maybe, but at some point it's become broken. You've got to remember that 165, even though it spans a long time now, and it's kind of very frustrating, it was unavoidable, unfortunately. The plan was originally to replace the runtime, then replace the compiler, and then replace the graphics engine. PlayBASIC, this is going back 6-7 years ago now. And something happened while I was in the middle of doing the runtime thing, which was, we were calling 165. And it's taken really all of that time to get 165 up to pretty much the same spec or beyond that spec of 164. It uses a different runtime completely than the old versions. So 165 is faster inherently than everything 164 can do. There are situations where it can pretty much match the behavior of 165. Yeah. Anyway, so what we're doing here is we're creating a vector, which really is just a package of 3 floats, though, isn't it? When you think of it, and we're assigning this into here. So what center is? It's a vector. Where are we? Here it is. Here. That's declaration. So we're copying these 3 floats across into here. Now there is actually another way you could do this. You could go Vector3 and then set sphere dot center. That's the exact same thing. Oh, sorry. That won't be possible because we've got I haven't got the Vector3 library in this example. The math libraries, they won't be part of the base. You'll include the math libraries or the Matrix3 libraries or the intersection libraries if you need to use them. Otherwise, you'll get collisions. Like I use this quite frequently, and other people do as well. I have my own vector declaration or whatever. If I build them in now, there'll be collisions with existing code bases and stuff, and I don't feel like going back now and updating old examples to avoid the collisions. Yeah, no. Anyway, if the vector library was included, that would be the exact same behavior. That's probably the best way of doing it, to be honest. But anyway, so we're setting this sphere here with these 3 values in here. It's a bit cleaner on one line, and we're making a copying this center position into sphere 2, displaying it. This is actually something that was an old feature that I don't know when this was changed. It was probably changed during 165, and whether it was broken or I don't really know. There's 2 ways of addressing of calling a pointer from within a structure. One of them is by using the field name, and one's by using the type name as well. So, I know there used to be a situation where that was necessary for some reason. I can't think of what it was off the top of my head. It's not so much these days. So back in the day, there was probably a reason for that, and over time, that syntax has been kind of loosened and dropped. So you can still use that syntax, but unfortunately, this was actually crashing in 165. Not with this behavior here, it was with the assignment stuff. So if you went pbsphere dot blah 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 dot pb underscore vector3, that would have crashed other versions of 165. It doesn't now. Works fine. But just putting it out there anyway. That was necessary for when you did a copy of a type from the right hand side to the left. It uses that structure name, that type name here, as for how this data is being copied from the right side to the left. I think that's pretty much what it was doing. Anyway, so on the next thing, we can assign it from function return. We can copy between the right to left hand side, which is what we're just talking about. Display them. We're displaying the same thing twice just to make sure that the phraser understands the syntax, because it wasn't there for a while. We can clear out that part of the structure, the center, that vector, and write zeros to all of it by just doing that. Display it. We can see this again. Now, because there's a pointer, you can grab a pointer from anything you like. So here I'm kind of demonstrating an idea where hey, I can have a floating point array, put some stuff in the first 3 indexes, the first 3 elements, if you like to call them that, of the floating point array. I have another pointer up here. I can ask PB for the pointer to the very first, or element 0 in this array. So that pointer is pointing at this bit of memory here. Wherever that happens to be in memory right now, that's where it's pointing at. So when I do a copy from here to here, sphere 2 is now filled with these values. Let me display it, go back. Here I'm doing the copy. This was crashing. This was actually, there's certain situations where this was actually working in some regards and then not in others. And I think there's demos that were testing this, that are out there that seem to work. But in this particular case, it was crashing. Go figure. It turned out there was a problem with the way these fields were copied across when the compiler generated the structures that represent the types in memory. I mean, it's a convoluted explanation, but that's actually what was happening. Because obviously, if we're going to copy something from this side to this side, we need to know what the structure of this memory is going to be in order for how we should copy it. If we're copying an integer or a float to an integer or a float, that's fine. We can just copy the memory across. But if we're copying an integer on one side to a float on the other side, or a string, that's not going to work. That's why we need to know the structures between these things. So this is that longhand syntax again, which I was just mentioning before. That's working again today. That wasn't working in 165 before. I think it was okay in older versions of 164, like the old Learning Edition stuff. If you're using the Learning Edition, dude, that thing is, I don't know, 15 years old. Even though the version numbers are close, they are nothing like each other. Anyway, again, we're using the same syntax, doing a clear of all of those fields, so we can write a null into those things. The only thing this responds to is writing 0 to clear out the fields. If you try and write something else into here, we get a syntax error. It doesn't understand what you want it to do. I've got a function there to display this sphere, which is just a few print statements, wherever it is, up here. Got the hiccups all of a sudden, fantastic. And that's pretty much it. So now in the Fraser in PB2, we're going to bring in more of these. Vectors will become as utilitarian as integers and floats. You'll just be able to go, hey, I've typed Vector2 and then do things with it. I do like the idea of having, say, like multiple returns, for example, or assignments between two multiple values is quite useful, actually. Like a classic one would be, you'd have like just a crappy example. If we had x2, let's say, equals x1. Doing well so far there. Something like that, right? We could express this here, y2 equals x1 comma y1, just to pull back some real estate in terms of the screen space. And look, there's heaps of these kind of things I think would be much better to have. Like, if you're getting reading a position from a sprite, for example, it'd be nice to just grab a vector from it and do that and throw that to do vector operations on that thing straight away. Again, a few less lines of code, it really adds up at the end of the day. Yeah. Look, I'm trying I'm trying to make this Fraser the best it can be for what it is, and it's a bit of a nightmare to make changes to. When I found out this was crashing the other day because the Fraser was broken, I was terrified. I was like, oh, dude, I don't want to spend another week banging my head against this thing. And it actually took the best part of a few days to work out why it was crashing. The solution was easy, and now it should never crash from that same problem. But you should never say never. Everything's always possible. But there we are. That's if you're wondering why I was changing the linkdll stuff, now you know. This is exactly what I was doing it for. And I think probably in a few more days' time we'll have a pretty complete intersections library, a pretty decent matrix library, and our base Vector3 library, and I'll add a Vector2 library there as well for consistency. So we have Vector2, Vector3. We could go forward and go crazy with some other ones, but I'd have to re-educate myself on those ones there. My math is pretty bad these days, so I haven't done much of it for a while, so bear with me. But we're getting somewhere, just not getting there as quickly as what people would like. I know that. But anyway, coders, all you retro coders out there who are doing crazy things, and like we all like to do, make old languages do crazy things. I'll see you next time. Bye.